Hello, welcome to our physics class. Today we are going to look at dimension. What is dimension? Dimension is the use of physical quantities, to describe measurements. So dimension is the use or referred to the use of fundamental physical quantities to describe measurement. The use of fundamental physical quantities to describe measurement. Remember some time ago we talked about physical quantities like length, physical quantities like mass, physical quantities like time. We said that these physical quantities, they are the fundamental quantities. They are the basic quantities on which other quantities is derived from, on which other quantity depend upon. That was what we said in our last class. The video, you can check on the video, our last video on quantity and units. You can check on that video. So today we are looking at how we use this fundamental quantity to describe other quantities, especially derived quantities, how we use them to do some analysis. We call those analysis dimension analysis. This is where we use dimension to check the consistency of physical quantities or physical equations and to derive the relationship between different physical quantities. You know, in dimension, when writing dimension, you have to put them in brackets, square bracket, and the letter or symbols that represent that quantity should be in capital letters or block letters. So the letter that represent the quantity should be in capital letter or in block letters. So mass, this is length is L, mass, capital letter M should be in in square bracket. Time, the uppercase T, it should be in square bracket. This is how we write them. We usually put them in this way. Sometimes you can put a numerical value around it, and we use it to describe the quantities. So let us look at a particular quantity. Let's take, which quantity can we use? Okay, let us take velocity. Let's take velocity. Let's take velocity as a quantity which we can try to find the dimension. We want to find the dimension of quantity, of the quantity called velocity. What is the dimension of velocity? So many exams do ask this question. What is the dimension of a particular quantity? Or compare which quantity has this particular dimension. They make a list of some dimensions. They give some dimensions, and they expect you to choose the one that represents the quantity they want you to pick. So let's look at velocity. The first thing you do is to look at the definition. Definition. This is our first step. This is our first method. The first method I'm going to use is look at the definition. What is definition of velocity? Definition of the velocity is displacement Displacement all over time. Now, displacement all over time. So the definition of velocity is actually rate of change of displacement. So we have displacement all over time, which is rate of change of displacement. Now, rate of change of displacement is represented as distance, or which is displacement all over time in a smaller symbol. So we can now say, let's look at what is the dimension of displacement. Displacement is a distance in a specified direction. Displacement is a distance in a specified direction. So since it's a distance, we represent it by our length, our L in square bracket, and time we represent by T, also in square bracket. Do you understand it now? Now, let's look at it. You can now say length divided by time, which is LT raised to power minus 1. You can check this out in our maths lesson. In our maths lessons, when we are dealing with indices, I took time to explain this kind of thing. When you do things like this, you say A all over M is the same thing as A all over 1 times 1 all over all over M. So we can say A is equals to M raised to power minus 1. A times M raised to power minus 1 is the same thing as A M raised to power minus 1. So that was what happened in this place. So I take it again. If you say A all over M, A all over M is the same thing as A all over 1 times 1 all over A, then you can now say A times M raised to power minus 1. So when you put everything together, you multiply A times M raised to power minus 1 is the same thing as A M raised to power minus 1. You check this out in our indices class. So this is what has just happened, and we have our dimension for velocity. The dimension for velocity is LT raised to power minus 1. LT raised to power minus 1. That is dimension for velocity. Let us quickly look at dimension for, let's take acceleration. Acceleration. You know, acceleration is rate of change of velocity. Rate of change of velocity, which means velocity all over time. Velocity all over time. Velocity all over time. You are aware that our velocity is s all over t again, so it becomes acceleration. This one is velocity, the whole of s divided by t, that is displacement all over time divided by time again. So there is time there twice. Time twice. So we now say, since this place is velocity already, let's just come back to write this displacement. Or well, let's write it in full. You have this one represent our L divided by our T. So we have it in square brackets. All over T again, also in square bracket. Also in square bracket. So if you work this out, you check our indices class, you understand how to use principles of algebra and all our indices. You discover that we will now have L t raised to power minus 2. That becomes the dimension of acceleration. This becomes the dimension of acceleration. You can also use a different method. You can use a different method to still find a dimension of quantities. If you don't want to use this definition method, using the definition, you can use the units. You can use the units to find them. Take, for instance, velocity. You can use the unit. The unit of velocity, which is v, is meter per second. Meter per second. So if you want to find the dimension of this, you can just say meter is L. Second is time, t raised to power minus 1. So it's just very simple if you decide to use the unit. But it's also nice, you know how to get it from the definition. So acceleration is rate of change of distance. Let's say acceleration, this time let's say the unit of acceleration, A, is equal to meter per second square. Just the same thing, this meter, you have the length, second is time, raised to power minus 2. So you can see the dimension of acceleration. Let's look at the dimension of force. The dimension of force, F, is equal to, this time we are not going to use Newton as the unit, but there's another unit that is very practical for us to use. That is kilogram meter per second square. Kilogram meter per second squared. So remember that force is equal to mass times acceleration from definition. But this time we are not using the definition, we are just using the unit, the practical unit of it, which is kilogram is mass, meter is length, second is time, and we have raised to power minus 2. So you put everything in square bracket, you have your dimension for force. So thank you very much. You just check on our other classes, some other classes that we've had on our YouTube channel. Thank you very much if you've gotten up to this point. Please kindly share this video, share the video, subscribe to our channel. Also, help us to press that notification button so more videos like this will come to you, and press the like button. Make good comments about our video. Thank you very much, and God bless you.